enjoy in real life is a theremin. What that is that's an electrical instrument that checks in between the pulses of waves coming out, and then you move your hands up and down, and then the pulse hits, and it's based off of where that contact's made is the sound and pitch that comes out. Usually this is found in scary movies where it's like woo, 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 going on and so forth. So we're going to do the light theremin. Basically what we're going to do is we're going to use a photo sensor in order to actually get this to work through it. Okay, so it's going to sit there and see the photo sensor and register that, and then as it goes, it'll judge it based off of how far away, how much light is coming onto it. So we're inside Tinkercad. We're at the Learn Arduino. Okay, you get there by hitting Learn, changing it from 3D to circuits, and then projects, all projects, light theremin. Okay, so you can see I've already worked through part of it. Today what we're going to be doing is we're going to be going through the introduction and the setting up the circuit. Okay, so the introduction for this is pretty neat. It's jumped ahead to where I was at. So it's time to make some noise. What we'll be doing is we'll be using a photoresistor and a piezo sound buzzer. You'll be introduced to a new function that controls the tone or pitch of the buzzer. I do have another speaker. I might be able to hook it up. We'll see. I might have to make a little box for it, and then we'll see what we can get from that. Okay? Okay. So it's time to make some noise. In this project, you'll utilize the photoresistor and the buzzer. What we're going to be doing is we're going to be basically setting it up, looking at the circuit. So we have the photoresistor coming out, and it's reading it through the A1, so 5 volts coming in, reading through A1, going through a 10K resistor, and then coming back into ground. And then the piezo is coming out through 8, so this is going to be your output. So this is input to output. It's going to be going through the piezo buzzer and coming back to ground also. Okay. So we need a piezo buzzer. Boop. There we go. We need a photoresistor. And we need a 10K resistor. So we need a 10K resistor. There we go. Okay. So we can see the circuit and how it's wanting us to do that. You'll see the negatives matching up. Make sure the negative. So the piezo buzzers, if you are doing this at home, the piezo buzzer does have a positive and a negative side. Make sure you hook those up. Otherwise, you'll invert the sound and it might sound a little weird. Okay. Okay, so what we're going to do is we're going to take this, we're going to drop this in. Okay, now the assumption is going to be, is this going to be, let's see, positive. Oh, I already hooked that up wrong. We'll drag that down to positive. Make sure that's red. This is negative, so our negative side. Black. Okay. So we can see that based off the circuit. So we don't want just power running through that. Okay. So this, we actually want to hook it up to port 8. Okay. And I'm actually going to change that. We'll change that to orange for it. Okay. So I'm going to throw the photoresistor in there. And then we're going to check to see which one's terminal 2. So we want to have terminal 2 going into negative. We're going to have this breaking off. And this is going to be the cable feeding into A1. Or A0, sorry, not A1. And then this is going to be positive coming in over here. It's our ground. So all we need to do is hook these up to our 5 volt and ground. Now this ground could go here. We're going to feed this around to our 5 volt. Okay. So now what this is getting into is this is going to start talking about how the PMWs, so the pulse width modulation, is going to be helped in controlling the LED brightness. So in other projects, on this project, you want the control of the vibration frequency of the film in the piezo buzzer to change the musical pitch. So basically what we're going to be doing is we're going to be utilizing that and mapping it out in order to send a different frequency to here, so it's bouncing back and forth at different frequencies depending on how much light or how little light it's actually getting. Okay, so when we're looking at this, we can see that, notice how the signal is low most of the time, but the frequency is the same as PMW 200. So PMW 50, analog right 50, so we can see the period distance in between is still 200 for the frequency, but the period is a longer period and there's not as much. Okay, notice how the voltage is high most of the time, but the frequency is still is the same as PMW 50. Okay, so the frequency coming up and then it's just active for more. Okay, the duty cycle is 50% on half of the time off, but the frequency doesn't change. So if we were to sit there and put the tone, so tone 440 is there. So if we were to hold it, okay, same duty cycle as 440, but twice the frequency. So you'll notice that it is higher. So our frequency right here is higher, but there's more time period in between. Or there's, it happens twice in between. So it's going to be the same if we add them all up. Okay, so using the PMW, the period, the pulse remains constant. You can control what percentage of the time the film is up versus down within each single period. As you learn in the color mixing lamp, this is called the duty cycle. Okay, so the frequency is the number of periods per second expressed in units of hertz or Hz, a 440 hertz tone cycle through 440 periods per cycle. Okay, so we have to find the photoresistor and the piezo components. We already had that. Okay, so in this, so we'll utilize what's known as this map function, and we're going to take in the analog value. We're going to set the min in, max in, and then the min out and the max out is what it's going to feed back to that buzzer to create that hertz. Okay, that's the first section done. Okay. So with that, we're going to get into the other part of the build side of it. Now what's going to be happening is it's probably going to be the same thing for us. Okay. Okay. So what it's having us do is take this, the 5 volt. Okay. Now we've already done this. So this is just review again for it. So it's the 5 volt over ground to ground. We're going to have our A1 or A0 come out, and I'm just going to drop that in. Okay. So we can pull out our piezo buzzer. Okay, we can change the wire if we need to. Okay, so this is our positive versus negative. Okay, so I question right now on here because they have the negative coming in over here and the positive, so the positive on the actual piezo buzzer is over here, and they have that going through, which can actually damage speakers if you have a positive and a negative switched on them. So we actually want to be going something like that. Okay. So now we're going to set up our photoresistor side. So we see analog. We already have the analog coming in, so it's going to be reading that signal. We're going to feed the 5 volts into it, and then we're going to be returning it through our resistor, our 10K resistor. Okay. So I'm going to move this down and around. Actually, I could have left that there. because that's going to our A0 or our analog. And then we need to find our photoresistor. And then we're going to bring in our positive. Okay. So with this is our setup for this. Okay. Tomorrow what you guys will see is we're going to work on the code. The code is a little bit more complicated. It's going to be a little longer video. But go ahead and get this built up. If you feel like you are ready to, you can hit done and hit continue and jump into the coding side of it. Okay. You can jump into the coding side of it. I need to jump back because I wrote through the code already. So we need to jump back and go through and do this. Okay. So you can see that they have this set up how I wouldn't set it up. Okay. I would actually have the positive reading over to the positive, the negative coming over. Okay. Okay. But tomorrow we're going to get into writing the code. Okay. How to make the Theremin work. Wednesday, I'm going to try to do the live build of it and get it down here so you guys can see it and then hear it work. And then maybe Thursday, if I can, sometime this week, I'll try to build that box for that other speaker. I got to look to see if I have a hole cutter that's big enough at home for it. So we'll check. We'll see what we can do. Okay. But go ahead and get this built and we'll see you guys tomorrow.